In the continuation of breakdown mechanism of solid, the types of mechanism we already discussed, that intrinsic ionic breakdown, then electronic breakdown, avalanche or the streamer breakdown that we already discussed, electromechanical breakdown also we have discussed, thermal breakdown also discussed. Now breakdown, in the continuation of the breakdown of solid dielectric, we know that in certain type of the breakdown, certain breakdown which does not come under the either intrinsic breakdown or thermal breakdown. So today's lecture will discuss regarding the breakdown which is not in the category of intrinsic or the thermal breakdown, but actually occurred after the prolonged operations. After long operation, this type of breakdown will we can find such type of a breakdown. These are, for example, breakdown due to the tracking, in which dry conducting tracks are formed on the surface of the insulating material for a long time. So as we applied the voltage to the insulating material for a long time, that will be the tracking will be produced, that is known as dry conducting tracks are formed. These tracks act as a conducting path on the insulating surface, leading to gradual breakdown along the surface of the insulator. So that will leads to the breakdown because of this conducting path on the surface of the insulating material. Another type of breakdown in this category is known as electrochemical breakdown. Means electrochemical breakdown, that chemical reaction is produced by the electrical field, application of the electrical field caused by the chemical transformation such as electrolysis, formation of the ozone, etc. Now in addition, failure also due to the partial discharge which are brought about in the air pockets inside the insulating material. So we know that in insulating material air pockets are there. So that in air pockets a partial discharge is produced, and because of this partial discharge we know that the air which is inside the pocket will discharge first, and it produces sparking. Because of the sparking, carbon particles are produced and it produces a permanent track on the insulating material. This type of breakdown is very important in the impregnated paper insulation used in the high voltage cable and capacitor. Now breakdown due to the traying and tracking. This is most important breakdown because of the long operation of the insulating material. Now in polymeric insulators, insulation is widely used for many engineering applications. Why? Because this material is tough, light in weight, easy fabricated in any complicated shape, and possesses excellent dielectric property. When a solid dielectric subjected to the electric stress for a long time fails, it fails, and normally two times of visible marking, we can observe two visible marking on the insulating material are observed on the dielectric material. They are the presence of conducting path across the surface of the insulation, there is one visible mark, and second, that mechanism where the leakage current passes through the conducting path finally leads to a formation of the spark. These are the two visible marking we have observed after a long operation of the insulating material. The spreading of the spark channel during tracking in the form of branches is called tree. There are two words, that is tracking. Tracking means the spreading of spark. Channels are produced. That channels that is the you can say the track of the to pass the sparking. That provides a path for the current. That is known as tracking. Now this tracking, which is in the form of branches of the tree. It you can observe that it is in the form of the previous. It is from the tree. We already discussed previously that treeing, that the tracking is formed in the form of tree, and that is why it's called the treeing. Now the insulator progressively gets coated with the moisture. We know that moistures are always coated with the insulating material. that causes increased conduction, leading to the formation of the surface tracks. That surface tracks are produced because of the moisture content. Now this is we know that this HV, if we applied H high voltage to any insulating material, I have already draw a figure that these are the two electrodes, which one is electrode is connected with the HT, second electrode is connected with the ground, and in between this is an insulating material, solid insulating material. This is solid insulating material. Now the moisture films are always there on the surface of the insulating material on the both the sides. Right. Now, if we applied high voltage, then the heat is produced. Because of heat produced, the moisture content, whatever the moisture content film on the one side, two sides of the dielectric material, that becomes a dry. I mean, drying of the conducting film will take place. This becomes a dry. When it becomes a dry, the separation, it produces separation between conducting film and the insulator, means there are gap produced between this film and this insulating material, so gap is produced. So as we increase the voltage, we know that the spark is produced in the gap. Always suppose there are loose connection, the spark is produced which damage the material, that damage the material in this way, like we damage produce a path damage, the sparking is produced. So because of the sparking, the carbons are formed, that is carbonize the region of the sparking. So this region, it becomes a carbonized region. Now because of this carbonized region, it form a permanent conducting channels, that is known as track. This is the track, it produced by such type of sparking. So this is a single track I have seen. So there are certain number of other tracks are also produced. So because of this channel, one channel, suppose this channel is connected to the other channel, third channel, fourth channel, fifth channel, and it forms a continuous path between these two electrodes. So when we increase the high voltage, the current will flow through this path. That is known as tracking mechanisms. How can we prevent the treeing and tracking? How can we prevent such type of phenomena to be occurred? So that treeing can be preventing by having clean, dry and undamaged surface, and a clean environment is required, because as the moisture content is there, always there are treeing and tracking phenomena for a long after operation of the long period. The material chosen should be resistance to the tracking, that is it gives the high resistance to the tracking. Sometimes moisture repellent gases are also used, so which remove the moisture content from the insulating surfaces. But this needs a frequent cleaning and regrazing is also required. So this is one precautions we have to take regular as a regular maintenance. Increasing the creepage distance should be prevent the tracking. So creepage distance should be prevent for the tracking. But in actual practice, the presence of moisture film defeat this purpose. Because of the moisture, we are failed to prevent a tracking and treeing. Now the breakdown due to the internal discharge. Now because of internal discharge, the breakdown will occur in the insulating material. Now solid insulating material contains voids and cavities within the medium or the boundaries between the dielectric and the electrodes, so that the gap it filled with the air. These voids are generally filled with the medium of lower dielectric strength, that is air, and the dielectric constants of the medium in the void is lower than that of the insulating material. So whatever the means air, suppose it filled with the air, so dielectric strength of air is also less as compared to the solid. Hence even under the normal voltage working voltage, the field in the void may exceed the breakdown voltage. So at normal voltage there is a breakdown. This is known as partial breakdown, means the breakdown due to the internal discharge, and this will form a track of carbons. So I have drawn this figure. Suppose these are two electrodes And this is the insulating material shown by the shaded part. So that will contain a cavity. The cavity has a capacitance of C1. Then C2 is the capacitance of the dielectric medium in the series with the void, like this. And C3 is the rest of the part, capacitor of the rest of the part. Now D is the distance between two electrodes, distance between two electrodes, or thickness of the dielectric material. And D1 is the thickness of gap of the this void. Now the V is the applied voltage, as we applied the voltage V. So V1 is the voltage across the void. Voltage across the void is shown by the C1 capacitance. The C2 will be shown by the C2. This part will be shown by the C2 capacitance, and this part will be shown by the equivalent to the C3 capacitance. So we have three capacitance: C1, C2 and C3. Suppose there is no void in the insulating material, only the one capacitance are there. But because of the void, the capacitance between these electrodes to the void and this terminal to the second electrode, another capacitance, and whole capacitance is known as C3. Now as we know that the equation for the V1, it is given by V, applied voltage V, D1 upon D1 plus epsilon 0 epsilon r D2. This is the series voltage, that is known as division of voltage theory. Now usually this D1 is always very less than D2. You can see in this figure also, D1 value is very small as compared to D. So we can neglect D1 here. So when we neglect D1, so we have this equation number 2, that V1 is equal to V epsilon r D1 upon D2. That we can have because of this. When we neglect this, we have equation like V D1 upon D2 and epsilon 1 upon epsilon 0. Epsilon 1 upon epsilon 0 is the epsilon r. So we can say this is the voltage across the this gap or the void. Now if we summarize all this internal breakdown, so as we increase the voltage, so what happened when we increase the voltage at V1, that is the V1 is the voltage in void. That V1 dielectric breaks and it produces spark, and V1 is equal to 0 again. Now the voltage increases, again void breaks and produce a carbon track. In this way, as we increase the voltage, more and more spark is produced in the gap. So because of that spark, erosion of the material will takes place, chemical degradation of the material is also takes place. Now the channels and the peat forms on the cavity surfaces increase the conduction. All this effect will result in a gradual erosion of the material and consequent reduction in the thickness of the insulation leading to the breakdown. So with this lecture, we have already completed the breakdown mechanism in the insulating material. Thank you.